entering from this side of the video, because I always do that side. This side just feels different. I don't know if I like it. Anyway, we did it. Outcomes and probability, lesson 2. An outcome is the possible result of an event. Okay, anything that can happen. Sample space, the set of all outcomes. Okay, so a sample space is just listing every outcome that is possible. For example, if I were to roll a 6-sided die, my sample space, my possible outcomes, I can have a 1, a 2, a 3, a 4, a 5, or a 6. Those are the only options. I can't roll a 7 on a 6-sided cube. If you figure out how to do that, you let me know, because you've done something special there. The probability is a chance of something happening. You all are probably pretty familiar with the idea of probability. It can be written 3 different ways: fractions, percents, and decimals. Now, there are 2 of these that I like more than the third. I like a fraction. I like a percent. I don't really like a decimal. Even though it technically is true, you could write it as a decimal. It's not how we think about it. So what's the probability if I flip a coin and I get heads? You'd probably say 50%, or 1 out of 2, because there's 2 options, right? Half of the time, you get heads. But you wouldn't say, what's the probability of me flipping and getting a heads? You say 0.5. That's not how we do it. What's the chance that we have a snow day? What's the probability we have a snow day? The tracker says it's about a 60%. You wouldn't say 0.6. So I like fractions, I like percents, and decimals. Sorry, you're going to be left out of this unit because I don't like doing that, because that's not how we do it. And then the symbol, this is read as the probability of event A. So the probability of A. The probability of rolling a die and getting an even number. The probability of flipping a coin and getting heads. Whatever that event is. So find the probability of rolling, or of each of these. Number 1, rolling a 2 on a 6-sided number cube. Okay, so here's how probability works. We always have our list of outcomes on the bottom, right? There were 6 options rolling a 6-sided die, 6 different outcomes. How many of those outcomes was exactly a 2? Just one of them. Okay, don't fall into the trap of putting a 2 up there because you see a 2. Only one of the 6 options here is a 2. Only one. 1 out of the 6. Now, can we reduce that? Not really. We could write it as a percent. We're gonna need to write both. I'm probably gonna stick to fractions most of the time. Rolling an even number. Okay. So I still have those 6 outcomes. Now, how many of those were even? 3, 2, 4, and 6. Reduce if you can. Always reduce. You guys are big boy math students. You should know to do that. Flipping a coin and landing on heads. So we just talked about this example. There are 2 outcomes. Only one of them is heads. Selecting a green marble from a bag that has 3 red, 4 green, and 5 blue. All right, sample space. How many different marbles are in this bag? 12. Of those 12, how many are green? Reduce that if you can. 1 over 3. You got a third chance to get your marble. Lila, someone is spinning a spinner with sections numbered 1 through 8 and records the results. Lila does not have a lot going on. Event A is spinning an odd number. Event B is spinning an even number greater than 2. Oh my goodness gracious. Draw a Venn diagram that shows. Okay. So event A, these were odds. And event B was a number greater than 2. Okay. And it was 1 through 8. Awesome. Now, where is the overlap? Let's write out all maybe of the sample space. Might help me. 1, 2, 3, 4, 5, 6, 7, 8. All right, where's the overlap? What is bigger than 2, but still odd? 3, 5, and 7. Now let's go back and grab the rest of it. The odds that weren't included, just 1. And then bigger than 2. Let's see, let's cross off the ones I've already done. 3, 5, 7, 1. Stuff that's bigger than 2 goes over there. 4, 6, and 8. But I have 1 left over. That 2 doesn't fit into either of these categories. It's not odd and it's not bigger than 2. 2 isn't bigger than 2. So it's excluded. We need to represent it in our Venn diagram, but it's not going to be in one of those categories. Okay. A tree diagram is a visual representation of all of the possible outcomes of things. It's really easy to make. It's also a little time consuming, but let's do one. Miguel is going to select an outfit from 2 different shirts. He's got a tan shirt and a red shirt. Someone get this boy some more shirts. 2 different pair of shorts, gray and khaki, and 3 pairs of socks. I think most of you probably only have 3 pairs of socks, so I think you can relate to Miguel here. Draw a tree diagram to represent all of his possible outfit choices. Okay. So we have his outfits. He needs to make a choice. Is he going to wear his red shirt or his tan shirt? And it's a big choice to make. But that's all he has. T-shirts, tan and red. So once he's picked the shirt, he has 2 more choices. His shorts. Gray or khaki. That's a G. Someone's going to comment how that doesn't look like a G, but it's a G. Okay. The boy has picked his shirt, picked his pants. Doesn't say anything about his underwear. Hopefully Miguel's wearing underwear. And then once he's picked those, he needs to pick what kind of socks he's going to wear. And he's got 3 choices for socks. So each of these needs to have 3 little spokes, because he's got 3 choices from there. And what are his socks? Black, navy, or white? Black, navy, white. Okay. So here, visually represented is the boy's outfit choice. He can wear his red shirt with his gray shorts with white socks. Or he can wear his tan shirt with some khakis and blue socks. Okay, those are all of his outfits. Now, let's see. However many little roots, the farthest point out, determines how many different outfits the guy can wear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dude has 12 outfits. Not that many. Hopefully he does laundry. Okay. Oh, we already did that one, man. I got ahead of myself. How many different outcomes were there? 12. What is the probability Miguel will select a tan shirt, gray shorts, and black socks? So, how many of these outcomes follow a tan shirt? I'm going to go down this tree. Gray shorts, this tree, and black socks over here. Only one of those make that happen. 1 out of the 12 different outfits that he has to wear. What's the probability he'll select an outfit with red shirt and gray shorts? Okay. So now we're in the red shirt and gray shorts. How many different outfits can he wear with these? Well, it didn't say anything about the socks, so we just care about 1, 2, 3. These 3 outfits have the red shirt and the gray socks. So 3 out of the 12, or 1 out of 4. What is the probability he will select an outfit with khaki shorts? Okay. So if he has khaki shorts, it doesn't matter if he's wearing the tan shirt or the red shirt. He's wearing khaki shorts, 1, 2, 3, 1, 2, 3. So a total of 6 of his outfits, or half of the time. And that makes sense that it's half, because boy only has 2 shorts. Okay? He's not living large in the pants department. Now, a tree diagram is a good way to visually see this, but it takes a lot of time to do that. So there's a better way. The fundamental counting principle. If for example, we're gonna make a tree diagram out of this problem, that would be terrible. Adelia's doing their sandwich stuff. They have 6 different types of bread, 8 meats, 4 cheeses. How many different combos can they make? Now, you wouldn't want to sit there and do little trees for all of these things. It would take way too long. So, there's a simpler way. Take however many choices you have. 6 different types of bread, 8 types of meat, and 4 types of cheese. If you just multiply your options together, you'll get the outcome. This is gonna be a big number. Can't do it in my head. It's too early, man. It's too early for that. 192. Now let's see if this would have made sense with Miguel's clothing situation. He had 2 shirts, 2 shorts, and 3 kinds of socks. If I multiply these numbers together, I get 12. And that's how many different combos he had to begin with. So that is a much faster way. But some people like the tree, and the tree is helpful in some situations. Hey, that's it. Look at that. We've gone through 2 lessons already.